Oh, hey guys, I didn't see you there. You guys weren't supposed to come till 12, but let's get started anyway. My name is Dranitsaris, and I'd like to welcome you to the 2015 Expo for Wind Power and Wind Turbines. Today we're going to be talking about the social and environmental aspects of a wind turbine. But first we have to understand what they are. A wind turbine is a large vaned wheel spun by the wind. Its purpose is to convert the wind's kinetic energy into electrical power for us humans to use. There are a lot of environmental positives which come from creating wind turbines. The first being, wind power does not generate any greenhouse gases, so there will not be an excess of greenhouse gases in our atmosphere which causes global warming. The second being that they are extremely space efficient. Building a wind farm or a wind turbine does not take up a lot of space, and it does not pollute the environment it is built in. And thirdly, we were going to talk about the wind. Wind is a naturally occurring entity which is everywhere in our world, which means wind power has the potential to be harnessed everywhere in our world and produce electricity anywhere in our world. This is extremely fascinating. Lastly, there is a negative. It was found last year in the United States that 0.02 to 0.52 million birds and bats were killed last year by indirectly or directly flying into wind turbines. Now let's talk about society. So, socially, because the wind turbines help our environment and bring down global warming, this will bring up global health. It will make humans healthier. And secondly, there is a negative. This is that wind turbines are extremely loud. They produce a lot of noise which can cause unease between the residents that a wind farm is near. And now let's talk about the money. Wind turbines produce a lot of money because the energy that they produce is far greater than the energy that is required to build them. On average, a 100 kilowatt wind turbine costs $350,000 to make. In 7 to 9 months, this wind turbine has already paid back that $350,000 in energy. So if a 100 kilowatt wind turbine lasts for 25 years, which it does usually, it will produce $13,125,000 worth of energy in its lifespan, and that is just for one wind turbine. So let's move on to our model. So we can see we're taking the wind's kinetic energy from the fan and converting it into electrical energy in the light. But we want to find the amount of power made by this. So we have our power formula. We must find the wind energy created. So wind has kinetic energy, so we could use our EK equals 1/2 mv squared formula. But mass in wind depends on density, area, and wind velocity, which I've given these three PAV variables. So mass equals PAV. We have our new formula. But according to Howard Betts, no turbine can capture more than 16 divided by 27 of the kinetic energy in wind. This is a law which we must follow. So we apply the coefficient into our equation. We end up with this. Now we're going to find the power in watts from our turbine and the turbine at the Toronto exhibition. So we have our air density, which is 1.2754. It is a constant. The area of one rotor and the wind speed coming out of the fan. We end up with 7.1 joules of energy created. Put this into our power formula per hours, and we end up with being 0.0197 watts of energy created per hour. The turbine at the exhibition, we have our air density as a constant. The area of one rotor is 52 meters in diameter, and then the wind speed is 113.33 meters per second. This is very fast. We end up with a large amount of wind energy created divided by time seconds per hour, and we get the power equals 7,910.5 watts per hour. Thank you for stopping by the National Exhibition. My name is Dranitsaris. Until next time.